G'day possums, welcome back to the lab. I've purchased a Hewlett-Packard signal generator, famously known as the HP8656A Signal. This unit does not work and requires a complete overhaul. This is a precision piece of test equipment that uses a lot of gold plating on its circuit boards. This Signal was generally used for servicing and repairing radio transmitters, TV transmitters, mobile phone towers, used in military communications, R&D departments, and even the space industry. But can I fix this important piece of test equipment? Enough talk, let's get started. So the first question you're going to ask is, what is a signal generator? Well, this is a RF signal generator, and you can see the little label there, and it can generate an RF signal or radio frequency signal between 0.1 megahertz or 100 kilohertz all the way up to about 1 gigahertz or 990 megahertz. And this is actually used to simulate radio frequency transmission. And I used one of these 30 years ago, servicing military radios when I was a lot younger, a junior technician. And basically it's a very simple device. We've got a little power switch here, we'll just turn it on. And what we could do is, if you're, let's say for example, if you're a technician in the 80s or 90s or even in the noughties, and you want to check a transmitter, a radio transmitter for example, and let's say you're at your local AM radio station and you need to check your local transmitter, and let's say it transmitted on 666 kilohertz. You dial it in, the devil's number, and there's our frequency there, and we can actually set the amplitude of that frequency, and we can make it higher or lower. We can set modulation or the AM modulation. So modulation is how much of the actual audio goes on the actual carrier. So we'll set it about 50%. And you can adjust how much energy you get out of here, and that's your amplitude adjustment. And you do that by jacking up the power like that. And you can hear some clicking in the background, and they're the attenuators. And that's basically almost like relays or contactors, just kicking in and out, just mixing in different resistors, networks and things of that nature, making the signal smaller or larger coming out here. And you'd feed this into the last stage of your big radio transmitter at the radio station, and that would actually test your radio transmitter. You can actually set it like a 1 kilohertz tone to transmit over that transmitter, and that could check the power output of your transmitter. You could even put in a microphone preamp here, and you could almost have your own radio station here and talk into the microphone and transmit on this frequency here. And on the other side of the coin, it could be used to check receivers. You may have a valve radio that you want to test on a certain frequency, let's say 900 kilohertz or something like that. You just dial in the frequency, whatever it is, set the modulation, 1 kilohertz tone, and you should be able to hear that 1 kilohertz tone in your actual radio receiver. So it can be used for transmission, it can be used for reception of radio, and many other types of things. So basically what we're going to fix today is we're going to fix the power supply. The power supply actually needs recapping. The capacitors in there are like 40 years old, so they need to be replaced, the filter Cappies. We also have the attenuators, and you heard those clicking in before, like that. They have to be checked to make sure the contactors are operating correctly and the contacts haven't blown out and just kind of dropped out. So we're going to check that. The keys on the keyboard, they're really clunky. This is clunky, very sticky. So we've got to actually have a look at the keyboard here. We'll take the keyboard out, and it's like any other sort of keyboard. we have a computer keyboard here, and this keyboard is exactly the same, except you have different characters on the keys, but it works the exact same method as a normal computer keyboard. So we're going to take that keyboard out, we're going to fix a couple of the keys. We're going to dodgy minus key down here, that's lost its spring, so we've got to fix that, and we'll fix any other faults that pop up in this overhaul. This is going to be a multi-episode kind of project, so there's going to be you know, maybe 4 or 5 episodes just to give this thing complete overhaul, and you can have a look at that in the description down below, the different episodes that kind of pop in. What we'll do is we'll take the actual handles off the side and we'll pop the covers, and we'll start working on those dodgy capacitors underneath, and we'll make a start right now. I remove the handles, then the side panel. The same process again on the other side. Flip the SigGen upside down. Bottom panel just comes up. And look at this. Look at all this fun here. These are the capacitors we're going to replace here. These are the big filter capacitors for various voltage rails within the actual signal generator. These two are original, but interesting. These two are new. So this has probably had some sort of catastrophic failure in the last 40 years. So all of these are going to be replaced, and we're going to replace a few other electrolytics around the board, because over time they actually dry out and they don't do their job effectively. And one word of warning, on this board we have a couple of UV protected EEPROMs, and they normally have stickers over the top of them, not so we don't expose the actual internal memory matrix to ultraviolet light, because if those stickers are not present and the light gets in there, those little EEPROMs will be wiped and you'll lose all the memory and the programming on those EEPROMs, and you are typically up shit creek if that occurs. So what we'll do is we'll fold this board out and we'll start removing capacitors. All the capacitors are being removed. This is our original capacitor, 13,000 microfarad at 25 volts, made in the early 90s by Sprague, and this is the more modern day equivalent. So it's, you know, less than half the length, half the thickness, and it's a lot smaller when compared to the original. And you can see how technology has marched on over the last 40 years. Also, this is an axial capacitor, leads at both ends, and this one here is a radial or single-ended capacitor here, and this will just have to go in that spot there, and we'll have to attach some wires at either end, so negative and positive. Strap it down, and we'll try and make it look a little bit sexy. So we're going to go off to the side right now and attach those wires, and we'll see how we go. Just get this capacitor in place, tighten up our zip tie. There we are, that doesn't look too bad. And what we'll do is we'll repeat the process to all capacitors going that way. That all looks lovely. Now I'm going to drop some hot snot over the top just to make sure these cappies don't go anywhere. Next, I'm going to check the voltage regulators. I spotted something very dodgy up the back. This is something I want to show you. We're just going to take off this little metal cover plate. Let's take out that last screw. These mostly are voltage regulators here. I think there's a rectifier mixed in there somewhere, but any which way, this voltage regulator here is not original. It's been repaired in the past and a new one's been put in. And do you remember me saying something earlier today? Interesting. These two are new. That's right. This little regulator here is directly connected to the old big yellow capacitor. So some reason in the past they've swapped them both out at the same time, whether the 5-volt regulator circuit just broke down and they need to replace both, who knows. But any which way, these two items are not original. What we're going to do now is we're going to push on and we're going to replace the last couple of capacitors, then we'll do a test power up. Hope this doesn't blow up. Nice, no smoke. We've just gone to the top board, the A3 board in our little RF SIGGEN, and it's time to test the 5-volt rail. Positive on the +5, and I will connect ground to we're all solid. Let's flick it over and we'll adjust our 5-volt rail. This is R79 on our A10 board, and we've got to adjust this to get it to 5.25 volts plus or minus 0.02. So that's something like 5.23 to 5.27. So first of all, we better bring up a multimeter. There we go, lovely. And we'll just turn on the power. just let our voltage settle a little bit. Okay, it's settled at, it's at 5.16 volts, so it's slightly out of spec. So I'll just give it a bit of a twist. Oh, that went up quick. Whoa, a bit too high. This is sparrow's fart stuff. A little bit more. There we go. I think that's as close as we're going to get it. You know, you just move it ever so slightly and it just jumps up to 5.3, so that's 5.25. So our 5 volt rail is all okay. So we'll check a few of the other rails now. We're just doing our 2 volt rail. Just got to find a nice ground. This looks good here. That's our negative done. Power up. Switch it on. And we're going for pin 4 here. 1, 2, 3, 4. And we're going for 2 volts plus or minus 0.004. So see if we can get this dead on 2. Well, going down a little bit. That's pretty good. That's as close as we're going to get. We are checking our last 2 rails on the actual power supply, and when I talk about rails I just mean the output of the power supply. So we've only got plus 15 regulated to go and minus 15 regulated to go, and you can see that we've got a green light here for minus 15 and a green light for plus 15. What we'll do is we'll check the rail voltage itself, because someone will have a good old whinge in the comments. So we'll just quickly bring up a multimeter. Here we go. So what we'll do is we'll check our minus 15, so that comes in on pin 2. You can count with me. We have 1 and 2, and minus 15.2. That's good enough. I'm happy with that. And our plus 15 is on pin 13. So we go backwards: 16, 15, 14, 13, and we've got plus 15.2 there. So I am all happy with that. Well, that's it. We've finished the power supply section of the HP8656A Signal. We've replaced the large capacitors here. We've also done a few other little capacitors around the board. We have calibrated the 5.25 volt rail and the 2 volt rail. We've checked that minus 15 and plus 15 volt rail as well. That checks out okay. In the next episode, we will check the attenuator. That's a very electromechanical device, and it's going to be fun to work on. Don't forget to check out all the videos in this series in the description down below when they become available. If you're interested in seeing other stuff repaired, check out the rest of our channel. Don't forget to share, like, subscribe. Other than that, we will see you next time in the lab.